Okay, I am now going to share my screen with you. Man. All right, y'all. I hope you all have something to write with and write on, because you're going to need to take some notes. All right, good people. So this is applied math. Again, all of you have been here before. So I don't believe any of you still need to enroll in the class. But if you do, there is the enrollment code. All right, so today we are talking about comparing data representations. And again, we are creating graphic representations of data, and we are looking at them. And in the end, we are going to see, or we are going to match two of the three representations that have been mentioned thus far in the class. And those representations are histograms and box plots. So the standard is there, again, according to the state of Pennsylvania. This is one of the things that we should cover, one of the topics that we should cover in this in this course. So our agenda, again, we're going to have a community meeting. We are going to do a warm-up where you are going to graph the same data in two ways. You are going to create a histogram of the data and a box plot. So I hope you have your notes. Then our lesson, we are going to talk about comparing data representations. We are going to do a practice where we match histograms to box plots. And then we will look at cool down 2, which is related to the practice. The cool down, for anybody who has not looked at it yet, you have 7 histograms and 7 box plots, and you will make 7 pairs. Okay, so let's get with it. Community meeting question, real quick. Oh, I'm looking at the question like, what? Question, where do you see yourself? I'm like, what? Where do you see yourself in 5 years? Again, you know, we are forward thinkers. Anybody? Where do you see yourself in 5 years?
Moving out of Philly, having my
Okay,
own business,
nice.
and probably having little kids, little kids around.
Oh, okay. So 5 years, that means you all will be somewhere between 21 and I don't think we have any 21-year-olds, but so somewhere between 21 and 26 for some of you.
Yeah.
Okay. So think about it that way. If you don't, you know, if you can't quite wrap your mind around 5 years, look at it from your age perspective. So for me, in 5 years, I will be 60. So in 5 years, I think I will be planning my retirement, you know, looking at where I am financially, where I am professionally, because there is a possibility that in, you know, 5 years from that, I will be retired. So think about it again, like I said, from an age perspective. Add 5 years to your current age, or if you a late December baby, 5 years to the age you are in 2020. So in 2025, how old will you be, and where do you see yourself? So Quay's moving. Let me see if somebody's chatting me. Yep, I got me some chat. Traveling the world. Okay, yep, that's a good one. That's a good one. And that's good. You know, you should want to see how other people live, you know. So that's a good thing. Anybody else? 5 years from now, like I said, you all, it'll be 2025. And you all will be somewhere between 21 and 26.
I want to get an RV. That's what I want to do.
Really? And do what? Drive? And what you gonna do?
I'm gonna turn it into a mobile studio. Cause in 5 years I'll be 24. So.
Okay.
You know.
Okay. Okay.
Big step or talk. You know me.
And 24 is a good age. That's a good age. But you want to be out of Philly by the time you're 24.
Yeah, I want to at least like be like down south somewhere, like North Carolina, South Carolina.
Oh, really?
Yeah, down there.
You want to move? Yeah,
I'm not. I all right. From born to now, I experienced traveling, but like I rather go down south because Philly is not about. Don't get me wrong, it's my hometown, but it's a lot of procrastination in Philly. Like it goes with a lot of people, but down south they get their business. It's a lot of people that's making it, and I've seen you can't make it anywhere, but I'd rather just go down south all over.
Okay. Yeah, they say a lot of progress is happening down south. Georgia, Alabama. That's not for me. I don't know that I could go. I might be able to go deep as North Carolina, but I don't know that I could go any further because their mindset is totally different from ours. Like there are things that we do just because that's the nature of what we do. And South bring a whole nother vibe sometimes. But I could go to Virginia. That's a part of my retirement plan. Because when I retire, I want to move to Virginia Beach. So in that 5 years, when I'm 60, that's going to be something I'm going to start doing, like looking at some places for me to live. How much would it cost for me to live down there? Stuff like that. How much do I need to make while I'm retired so that I can still live comfortably and not really have to like change up how I do what I do? Anybody else? All right. So for those of you who didn't respond, plan your work and work your plan. Okay? You going somewhere. I think you should figure out where that somewhere is. You make the decision. Don't let somebody else make the decision for you. Okay? So again, think about planning. When you all talk to Mr. Luke, that's what you all talk about. You talk about your plans. What is your plan and how are you going to get there? So again, think about where you see yourself in 5 years long term. And then, you can break it down year, months, weeks, days, and then work your plan. So, okay. So now, our review. On Tuesday, we had a different set of data than the data we're going to use today. So we represented that data in 3 ways. We represented it in a dot plot. And again, the strength of the dot plot is that you see each term of the data set. Okay, now this dot plot is not exciting because there are no repetitions. Everything in our data set was just represented one time. So that's what that data set would look like. But again, a dot plot is for small amounts of data, because if not, how long you would have a line that goes on forever. Okay? So the strength of a dot plot is you can use it with small sets of data, and you can see every term of the data set. Then we talked about a box plot. And remember, a box plot is a 5-number summary of the data. The ends are the minimum value and the maximum value, and the box is constructed from the medians. The median of the data set is found first because that is the middle. That is the 50% mark of the data. And then you find the median of the lower half of the data and the median of the upper half of the data. And that is your box. So again, the strength of a box plot is it gives you a quick glimpse of what's happening. So if you look at this box and whiskers, it's a couple things, or this box plot, you can tell a couple things about the data. You can tell the range of the data because you have the minimum and the maximum value. You can tell the middle of the data because you have the median here at Q2. Okay? You can tell how far, or you can tell the range between the middle of the lower half and the middle of the upper half. And that's called the interquartile range. Okay? You can also see that a small portion of the data goes between the minimum and the middle of the lower portion of the data. And you can also see the distance between the maximum value and the middle of the upper portion of the data. Okay, so again, in a box plot, its strength is, again, it's a 5-number summary. If you just need a glimpse of some data and you don't need any detail, you can use a box plot. Okay, and you would know that 50% of the data, because remember, there are 4 parts to a box plot. And the 4 parts, you know, just like a dollar, are called quarters. And that's what these Qs are. Okay, so the middle of this quarter, the middle of the whole thing, the middle. Okay, so 4 quarters. So the strength of the box plot, 5-number summary, quick snapshot of your data. And a histogram. A histogram is a continuous graph with no spaces in between. You will see that the beginning of, or the end of one bar is the beginning of the next. So the data is continuous. The data is grouped into equal parts, or bins, we call them. So they're divided into equal bins. And the strength of the histogram is you can use it with large sums of data because, again, you are grouping them. So its weakness then, just as grouping is its strength, grouping is also its weakness because you can no longer talk about the individual terms that are in the graph. Okay? So again, in this first bin between 3 and 7, we have three terms. Now, if we didn't see the data set, we wouldn't know what those 3 terms were. We would just know between 3 and 7, because remember 8 gets counted in the next bin, there are 3 terms. Okay? Between 8 and 12, there are 2 terms. Between 13 and 17, there are 2 terms. And between 18 and 23, there are 2 terms. But again, we will not know what those terms, what those terms are if we use a histogram. So again, 3 representations of the same data. So what I want you all to do is construct a histogram and a box plot using this data set. I have 940, so I am going to give you until 950 to construct a histogram and a box plot using the data on the screen. And I will also be doing it here on my board. So you are going to construct a histogram and a box plot. So I hope you have some notes. That's why I asked you to take notes, so that you'll have something to refer to when we do things like this. Oh. Oh, man. Okay. Sorry about that. Oh, let me write the numbers up here. Again, put this in your notes, ladies and gentlemen, because it'll help you later on. right, we have about 3 minutes. And ladies and gentlemen, because you don't have your cameras on, I am hoping that you are diligently trying this. It will only help you. You know, math is a verb. You have to do it in order to get better at it. So I would just hope that you are taking advantage of, the practice so that you will be able to do it later on when required. So I am going to stop the share because you all are going to need to see me right. I was making sure I don't have anybody else in the. All right, so. Okay, 2 minutes. We're going to start with the box and whiskers. All right, true to my word, it's 9:50. So, since we are starting with the box plot, the first step is to put the data in numerical order. So, somebody tell me what you got when you put the numbers in numerical order.
All right, so for my max, I got 125. That's right. I for some reason I work my way down. I start my way.
All right, 125 is the max. I'm there.
And then my minimum I got 89. That's right.
All right, minimum you got 89. Well, tell me put the data in order.
All right, so I got 89. This is the order. 89, 92, 93, 94, 99, 100, 107, 111, 119, 125.
All right, I agree. All right, so now I am going to shoot. Almost dropped the computer. All right, so now I am going to. Can you all see my board?
Yes.
Okay, so that's our data set. Now I did it. Mine was a little wicked. I could have started it over. All right, so our data set goes from 89 to 125. I agree with the order. So now, first things first. Now that you have identified, well, the second thing. Now that you've identified the max and the min, what's the middle of the data set? Because good morning. because there are how many terms? How many terms in this
This is actually terms.
how many terms?
What you mean?
How many terms in the data set?
Oh, it's 10.
All right. So since there is an even number of terms in the data set, how are we going to find the middle of the data, the median, Q2 of the data?
Like I X 90, 89, 125, 119, 92. All that until I got the middle, I got 100.
Anybody else got 100 for your Q2 for the median of the data set? No, wait, Quay. Hold your thought. Anybody else got something different?
We're gonna go from side to side because it's even, so it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. Hold on. 1, 2, 4, 5.
It's even.
7. Yeah, so then you just count 5 from each side and then in the middle, right?
All right. So what does that? So that means we got what and what? Because it's even. We came in
99.
5 here. What we do?
99.
And that's 5 from this side. Come from this side. Where you at?
1, 2, 3, 4, 5. 1, 2, 3, 4. 94.
I said come from the right side.
I don't know. You keep moving this camera and I'm missing some of the numbers.
Oh, I'm sorry.
It's cool.
Can you see it? Can you see it now?
Yeah, all right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. So 99 in the middle with both sides of those 5.
No, because it's 10 numbers.
1, 2, 3, 4,
99
5.
and 100.
99 is 5. Then 100 is 6. Then 107 is 7. Then 111.
So it's 100.
Look, remember, you come from both sides to find the middle. You came in 1, 2, 3, 4, 5. You went in 1, 2, 3, 4, 5. So it's even. You got to add these two together because 5 from the left got you 99. I agreed with you. And that's why I said to you, now come from the right.
Oh, now I see what you're saying.
Yeah, okay. Yes. Right. So now, talk to me, somebody. We got 99 and 100. What we going to do?
Add them together, right?
Yep. And
you're going to get 200.
99 and 100.
Oh, yeah, 199.
Yep. We taking the average.
Don't you got divided by 2?
Absolutely.
I get 99.5.
So, because the data set is even, we have to take the middle 2 terms. So we came from the left 5 and got 99. We came from the right 5 and got 100. So we had to take the average of the 2. So 99 plus 100 gave us 199, and we divided it by 2. So
99.5.
It's 99.5. So what you now need to do, ladies and gentlemen, is mark on your data set, put in the middle. Because 99.5 is not a member of our data set, but it is the middle. So note it between 99 and 100, because now your lower quartile, your lower portion of the data is going to be, while you're trying to find Q1, you're going to have 89, 92, 93, 94, and 99. If you don't write 99 and a half in there, you're going to get the wrong Q1 and Q3.
That's something that's due.
This is reinforcing what we are going to use, because we are going to talk about. Say it, ma'am.
I said, because I'm just now joining.
Oh, okay. Yeah. So I'm making sure that you all understand how to construct a box plot. Yeah, because and it's also a box and whiskers, if you remember from middle school, because it is going to help us when we start making our comparisons, box plots to histograms. So I need to make sure you got the foundation pretty tight.
So just when you post it on YouTube, this class, I guess I just started from the beginning because I just joined at 9:51.
Oh, okay. Yes. So as soon as the tape is available, I will post all of the 2 classes from this week.
Okay.
I will put them up on the YouTube channel. Yes.
All right.
Okay. So now, ladies and gents, like I said, we found the median of the data set. We found it to be 99.5. So now we put in 99.5 and look how it splits the data. It now does split the data into 5 on one side, 89, 92, 93, 94, 99. And it also gives us the upper portion, which now has also 5 terms: 100, 107, 111, 119, and 125. So now let's find the median of the lower portion of the data. So now we're only looking here. What is the middle value? We just looking here. The middle. Just look right on these.
And where?
89, 92.
Them numbers is down there.
Yes. Because now we split the data.
Your number is uneven. Is it gonna be 92 and a half? Like,
How many terms you got now?
5.
So can't we find the physical middle? Do what you did the first time. Come in. You came in, boop, boop. Came in this way, boop, boop.
93.
Exactly. So now, 93 is the middle of the lower end of the data. And now, what is the middle of the upper end of the data?
111.
What'd you say, love?
111.
Absolutely. So now we have
you gonna give me some participation, right?
Say it, love.
I said you're gonna give me some participation, right? Even though I joined at 9:51, but
yeah. The fact that you here, you get it. Absolutely. So now, ladies and gents, the minimum we found to be 89. The maximum we found to be 125. So those are the first 2 numbers in our 5-number summary. And now here are the other 3. So the middle of the lower quartile was 93. The middle of the upper quartile was 111, and the middle was 99.5. So is 99.5 closer to 93 or closer to 111? Oh. You got $99.50. Is it closer to you having $93 or you having $111? That make more sense when I talk money, right? $99.5 is 6.5 away from the lower quartile, but it is 10.5 away from 111. So when you place your quartile 2, when you place your median of the entire data set, it should be closer to the middle of the lower quartile than it is to the middle of the upper quartile. So this is what your box plot should have looked like. If you do not have that, please make sure you write it down. I can't back up any further, but I can use, you can tell me to move left or right if it's something you cannot see. And again, they're trying to work on getting me a camera where I could actually just write this on paper and the camera will be, you know, focused on the paper. And then we won't have to use the board as much. Did everybody get what they need? Or are we still kind of working on it? But the key here, ladies and gentlemen, I must stress, write in wherever, if you have an even set of terms in your data set, when you find Q2, the median of the entire data set, remember to put it inside of your data set, because again, if you do not, you will then miscalculate the middle of the lower quartile, the lower half of your data, as well as the middle of your upper portion of the data. Okay, we okay with the box plot? Okay, you know what I say, your silence is consent. All right, so I'm gonna take out the math of the box plot. I'm going to keep the data set, and I'm going to also take out the median or the Q2 value, because we don't need that for our histogram. So now, can somebody tell me, how did you break or group the data? So now remember, for the histogram, you need a frequency table, or you need a table to organize your data. Okay, and you only need necessarily 2 columns. How did you break them up? Remember, the bins should be equally spaced. And then the frequency, how often does a number fall into that category? So, somebody want to share how they broke down their bins? Remember, that is your choice on how they break down. All right. So teacher has a suggestion. You see that the numbers go from 89 to 125. So let's say we do the bins in groups of 10. So we'll go from 80 to 90, 90 to 100, 100 to 110, and 110 to 120. Okay, so now we can, and then we would have to go 120 to 130. Okay, and remember, in this first bin, we count from 80 to 89. So looking at the data, from 80 to 89, we have 1 value. So this is the only thing that goes 80 to 89. In this second bin, from 90 to 100, we count from 90 to 99. So this goes in the second bin. We have 4 values. From 100 to 110, we count 100 to 109. We have 2 values. Okay, so again, remember, the upper value goes with the next group. So in this first group, we only count 80 to 89. In the second group, we count from 90 to 90. Yes.
It's a glare. I don't know if it's from your computer or mine.
All right, let me see. Can you see it now?
Yeah, a little bit.
Let me see. If I turn this way, is that better?
Yeah, you know my blind behind can't see that, Miss Hicks.
All right. Does that work better?
Yeah, that's fine. That's right there.
Okay. So again, in the first bin from 80 to 90, you are only counting the numbers from 80 to 89. So we have 1. In the second bin, we are counting from 90 to 90. The bin is 90 to 100, but inside of the bin will only be the numbers from 90 to 99. So there are 4 of them. In the third bin, we will count the numbers from 100 to 109, and we have 2. In the next bin, from 110 to 120, we count from 110 to 119, and we have 2. And then from 120 to 130, we count 120 to 129. And we have 1. So your frequency table Remember, the bins go across the bottom. So we started at 80. Then we went to 90. Remember, you tried to space your graph so that they are equal distance apart. 100, 110, 120, 130. That's the end. So now, up the side is the frequency. So remember, you gotta label your graph. So we only need to go up to 4. So let's say 1, 2, 3, 4. All right, so those are our axes. Oh, I'm sorry, I need to stand over this way. Those are my axes. So we are now going to use the frequencies to graph. So between 80 and 90, it is 1. Remember, there are no spaces. Between 90 and 100, there are 4. Between 100 and 110, there are 2. Between 110 and 120, there are 2. And between 120 and 130, there is 1. So that's what your, and you could color it in if you like, but that's what your histogram would have looked like. So this is the histogram and the dot plot of the same data. Okay. But again, with a histogram, you will always find a frequency table. If you don't see one, if you don't see a table, you create it. And remember, you determine the width of the bins. I just made it 10 because it just made sense to me, because we were dealing with 80s, 90s, 100s, 110s, 120s. So that just made sense to me. Now, some of you may have made your bins smaller. Because this ended at 125, you may have made your bins in 5s. So you may have gone 80 to 85, 85 to 90, 90 to 95. If that's what you did, that is fine. You would just have more you would have more bars on your graph. But again, we all don't think the same way. So we don't necessarily always come out with the same picture, but it doesn't mean that you are not correct. Okay? Make sense? Okay. So I want you to finish that up. And we're going to have a discussion. And then I'm going to skip to this slide here. All right, ladies and gents, I am going to present, and I want you all to please copy these 3 sketches so that we can talk about them. Okay, so again, I am sharing my screen with you now. Hey, Salam, how you feeling, honey? I know that was you with the answer. We're answering the questions.
Yeah, hi.
How you feeling? All right, so ladies and gents, I want you to, this is like going to be our go-to note for this next section as well as for your progress report. I mean, your cool down, I'm sorry. All right, so we talked about, and I'm going to talk while you write. We talked about the 3 shapes of a distribution. We know if it's left skewed, the tail is on the left, all of the data has been pushed to the right. And we know that, again, the median, the Q2, is the best measure of the center of the data. Well, now, under our left skew, you see the box plot. So now, please start with the left skew, because here is what I want you to write. So again, we know what a left skewed histogram looks like because we know what the graph is. Okay, we know, again, tail is on the left, most of the data is on the right. But let's look at the box plot. So if the box plot is left skewed, you will see the left whisker is longer than the right whisker. That's your first characteristic. And I'm going to write it too. I'll write it on my board. Okay? So again, for the box plot, if it is left skewed, the left whisker is longer than the right whisker. The Q2 is closer to Q3. So you see that the median of the data set is closer to the middle of the high end of the data. Okay? So if it is left skewed, the left whisker is longer than the right whisker. And Q2 is closer to Q3. So again, the median of the data set is closer to the median of the upper end of the data, or the top half of the data. We ready to move? Okay, so if it is a symmetric distribution, we know we can split it down the middle and the left side is going to look like the right side. And in a box plot, you will see the same thing. You will see the median, you will see the whiskers are about the same length. And you see that Q2 is in the middle of the box. Make sense? So again, in that box plot, everything is even. Just like if it's symmetric. We can split it in half and the left side looks like the right side. And then lastly, we have a right skew. And in a right skew, opposite of what was a left skew. So in a right skew, the right whisker is longer than the left. And in this instance, Q2, the median of the data set, is closer to Q1. It is closer to the middle of the lower end of the data. Okay? So you see how these two graphs match up. So now, for those of you also who might want to take a screenshot, this is the screenshot to take. So in our...
Can you go back for a second, Jake?
I can.
Thanks. All right, thank you.
So again, your assignment from Summit, and it will be due by midnight tonight. I'm going to go on Summit and show you your cool down for people who have not looked at it yet. But I see 3 people have. That's a good thing. All right. So here is what they want you to do. So at the top, oh, excuse me. At the top, you have 7 histograms. At the bottom, you have 7 box plots. They want you to match the box plot to the histogram. And again, you are just going to it's about observation. So for instance, let's see E. So what we see in E is we have this bulk of the data is happening between 64 and 70, let's say 3. But then we have some things laying out front that is not connected to the graph, and we have some activity behind the bulk of the data. So when we go down to the histograms, we are going to look for something constructed the same way. 3 off by themselves, the box and whiskers here, and then 3 off by themselves. So when we look down on the bottom, we have, look at, box plot number 4. We have 3 standing out front by itself. Then we have the box and whiskers of the data. And then we got 3 out here away from the bulk of the data. So histogram E matches box plot 4. So your answer would be E4. Make sense? I'm going to have lab this afternoon, so don't panic. Okay, but that is what your task is. Again, you will look at the graph and you are going to look at everything. So for C, you are going to notice that C starts somewhere like maybe 47. The bulk of the data goes to maybe 67. And then you have these 2 things sitting out here away from the data. Those are called outliers. Anything that is away from the bulk of the data is an outlier. So again, you see the bulk of the data, and then you see you have an outlier somewhere between 70 and 74, and you have another one somewhere between 77 and 79. So when you look down on the bottom, that's what you're going to look for. Okay? Make sense? Okay, your silence is consent. So